sodium borohydride. Our total valence electron for sodium borohydride is 8 electrons. Equals 8 electrons. And I already went ahead and drew it out for you. Again, sodium is drawn out to the side because it forms ionic bonds. It's like kind of floating in the solution, if you can imagine a solution. And then the boron, you have to kind of know that boron usually does not fit the octet rule because a neutral boron would have 3 bonds and 3 valence electrons. So the fact that it's forming one extra bond, it carries a negative charge because it has 2 extra electrons, so it has a negative charge, which makes sodium the positive charge. Okay, we're going to do one more. We have sodium borohydride with a cyanide. Okay, so our total valence electron, 1 from sodium, 3 from boron, 3 from 3 hydrogen, 4 from the carbon, 5 from the nitrogen, which gives me a total valence electron of 16. Okay, here is the wrong way of doing it. You cannot say that the carbon is bonded to boron, bonded to nitrogen, with 2 lone pairs left over. You cannot say that because that would put a negative charge since it's missing 2 extra bonds, and it will put a negative charge here. This negative next to a negative in in general in any chemistry attracts to the opposite, and repels like. So a negative cannot be next to a negative. So you automatically should recognize that this is the wrong way of drawing it. Why? Another way of seeing it is that there's no octet on nitrogen. Notice that nitrogen is left over. There's no octet here. And carbon does not form 4 bonds. The neutral carbon should have 4 bonds, but here you're only showing 2 bonds. Okay, so that's wrong, and let's go ahead and do it the right way. The right way would be to draw the sodium. You got that part right. And then you would have the boron bonded to 3 hydrogen, and I see it's bonded to a carbon, bonded to a nitrogen. What I would do is draw in my lone pair, because this gives me my full octet of 16, but then I would go ahead and take these lone pairs right here, take these lone pairs and convert it into a bond between carbon and nitrogen so that carbon can have 4 bonds and nitrogen can have a total of 3 bonds. Let's see what that turns out to be. That gives me sodium again by itself, boron bonded to 3 hydrogen, bonded to carbon, which is triple bonded to a nitrogen. And let's go ahead and complete the octet. How many electrons have we used out of the 16? We've used 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We're still missing 2 electrons, and I'm going to go ahead and place that in my nitrogen. 15, 16, and that is your complete Lewis structure, with the addition that boron should have a minus charge. If sodium has a positive, then boron should be negative because our total formula is showing neutral charge. It has no charge, but in solution, the sodium will be floating around. And that is your complete answer. We're going to do one. Let's do this one. Notice how we have brackets with a total charge of positive 1. What is our total valence electrons here? Here, my total valence electron is 15 electron. Now I'm going to subtract 1, which will give me 14 electron. Again, I'm subtracting 1 because my net charge is positive. So to get a positive, I would take away an electron. I'm going to go ahead and draw that out. And I see that there is a hydrogen bonded to an oxygen, bonded to a nitrogen, bonded to 3 hydrogen. I'm going to count how many electrons I've used so far. I have used 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of the 14. So I'm going to go ahead and add 4 more electrons to the oxygen. 1, 2, 3, 4. So, and I'm going to double check. Do nitrogen, okay, let's go back and say, does my oxygen have a full octet? Yes, it does. Does it have 2 bonds like usually? Yes, it does. Does my nitrogen have full octet? Yes, it does. But remember that a neutral nitrogen usually forms 3 bonds. So we have 1 extra bond, right? We have 1, 2, 3. This 1 extra bond that would make it a positive charge. There you go. So my nitrogen is positive. And that is your overall answer for your Lewis structure. Okay, let's go ahead and do, I think we have one more. Here you go. Here's the last two examples. We have a methyl cation and a methyl anion. So let's go ahead and do our total valence electron for both of them. Total valence electron for a methyl cation is, we have a 4 plus 3 hydrogen, which is 7. We have a net charge of positive, so I'm going to subtract an electron, which I get 6 electrons for the total. Here, for the anion, I have 7 again, and this time I have a net charge of minus. To get the minus charge, I'm going to add an electron, since electrons carry negative charge. So I'm going to add one more electron, and I get a total of 8 electrons. See the difference between positive and minus? It can really give you a different structure. Okay, so I'm going to go ahead and draw it in. I see carbon bonded to 3 hydrogen. And sorry for my handwriting. And let's go ahead and count my octet rule. 1, 2, 3, 4, 5, 6. I only have 6 electrons. And does that match this total valence? Yes, so I cannot go more than my total valence. So this is my structure, and carbon must be the one with the positive charge. Okay, let's go ahead and draw the second one. The anion. I have carbon again, bonded to 3 hydrogen. Let's see if we have the total valence electrons correctly. I have 1, 2, 3, 4, 5, 6. I only have 6 out of the 8. So this carbon must have 2 more electrons. Okay, 6. I have 1, 2. Now we can count. We get 2, 4, 6, 8. 8 total electrons matches up. Perfect. And notice that carbon is missing one bond and has the full octet. This must be a negative net charge. Carbon must have a negative net charge. And that's your answer. Notice the main difference. Here you're saying that carbon only has 6 total valence electron and it has a positive charge since it has 2 less electron. Here you're saying the carbon has a full octet but it's missing one bond, so it has a negative net charge. Hopefully that helped you guys out. Last thing I want to say is, if you guys liked the video, please subscribe and give me any video topic suggestions, your current Orgo lectures, whatever your teacher, professor is teaching you. And another thing is, I am free this summer, so you can email me any Orgo 1 or 2 related questions at learning.organicchem@gmail.com, and I will help you to my best ability. Good luck, guys.